Hello, Professor. We are Group 7, and today we'll be presenting our Wireless Sensor Networks course project. Our work focuses on simulating a wireless sensor network in Omnet++ and analyzing how routing protocols behave under controlled conditions. Specifically, we evaluated the performance of routing protocols using key metrics such as end-to-end delay, packet delivery ratio, and energy consumption. In this presentation, we will first describe our scenario and system architecture, then discuss the simulation methodology, followed by the results and interpretation. Finally, we'll wrap up by the main insights and possible future extensions. Uh, Coming to slide 2, we have a project overview. The primary objective of this project was to evaluate and compare the behavior of two routing protocols in a 20 node WSN under the same conditions. All experiments were carried out using Omnet++ 6 version, which allowed us to model the network topology, application traffic, and protocol logic in a repeatable way. We considered a baseline routing protocol and a hybrid routing protocol so that we could see what performance benefits, if any, and the hybrid approach provides. Our evaluation focused on three fundamental WSN performance metrics: end-to-end delay, packet delivery ratio, and energy consumption, which together capture both efficiency and reliability. To ensure consistency with the course setup, we used the professor provided config g7.ini file so that our results align with the aligned group 7 scenario and can be reproduced. Coming to slide 3, which is assigned scenario. The assigned scenario consists of a 20 node WSN where all nodes are statistically placed. There is no node mobility, so the topology remains constant throughout the simulation. Each node generates one data packet per second, which imposes a uniform and predictable traffic load across the network. The radio parameters, such as transmission power, byte rate, and sensitivity, and the random seed values are fixed in the configuration file to make our experimental runs fully reproducible. Because the environment is controlled and there are no external disturbances like mobility or variable channel conditions, it allows us to focus solely on the intrinsic behavior of the routing protocols. Overall, this scenario is designed to represent a stable, lightly loaded wireless sensor network, making it suitable for baseline performance evaluation before introducing more complex dynamics. And the coming slides will be explained by my friend. Thank you.
So coming to the slide 4, the simulation is mainly built on Omnet++ 6.x using the iNet framework for wireless communication. Each sensor node is defined in node.ned, which shows the structure of the node. The app.cc creates data packets and measures end-to-end delay. The routing-base.cc gives a common interface for routing protocols. The baseline routing.cc implements a basic static routing algorithm. The hybrid routing.cc is an improved routing protocol with proactive and reactive features. All radio and network parameters are taken from config g7.ini for fair comparison. And coming to slide 5, it is routing protocols. The first, baseline routing, it uses a simple text hop forwarding method. It has very low overhead, no route discovery or control packets. It does not consider energy or link quality. Good for specific networks, but can deplete some nodes faster. And coming to the hybrid routing, it combines proactive neighbor information plus reactive recovery. It knows nearby nodes and selects routes smartly. If a path fails, it sends a recovery broadcast to find a new route, which helps to reduce the congestion and improve the reliability. By comparing both of them, we can see that the baseline and is equal to simple and basic routing method. And coming to the hybrid, it is an advanced method expected to perform better in dynamic cases. And then next slides will be explained, my friend.
Oh, so coming to the simulation workflow, here in the build simulation, first we build the Omnet++ project using the opposite make -f deep f group with the group 7 hour parameters to prepare the executable. So this command generates the make files and compiles all the C++ modules, including the app.cc, routing base.cc, baseline routing.cc, and hybrid routing.cc files. So the result is an executable name that which is stored under group 7. So in the execute simulations, we run three independent simulation instances using our professor assigned config 7 ini. So here the running multiple instances allows us to average results and reduce the impact of any single run randomness even with fixed seeds. And in the collect data one, during the simulation, Omnet++ and INET produce scalar and vector files. So vector file stores time series data like per packet delays, and the scalar file store aggregate statistics like total energy consumed per node. And in the analysis of results, we post process the scalar and vector files using a custom Python script. This script extracts metrics, computes statistics, and generates plots such as histograms, CDFs, and bar charts for energy and PDR. So by structuring our work this way, we separate simulation from analysis, which makes the workflow modular and reproducible. So coming to the next slide. Here we summarize the metrics we compute from the simulation outputs. In end-to-end delay from the vector file, we extract the delay for each successful received packet. Delay is computed as arrival time minus generation time. We then plot both histograms and CDFs to visualize the distribution of delays, not just the mean. And in package delivery ratio, uh, PDR is defined as total packets received by total packets sent, and high PDR indicates a more reliable network. And energy consumption in energy values are derived from scalar fields that track total energy consumed and remaining energy per node. So typically the radio module dominates energy usage due to transmission and reception costs. So together these metrics lets us analyze the latency, reliability, and energy efficiency, which are the three key dimensions of performance in wireless sensor networks. The next slide will be continue, my friend.
Okay, so the next slide
Okay,
is
so
the
the next
results.
slide is the results. Here, the simulation showed an average end-to-end delay consistently between 60 and 65 seconds. Delay values remained unstable, like stable across all simulation runs, demonstrating predictable packet forward behavior. Minimal jitter was observed, indicating a low variation in packet delivery times. No major congestion or routing bottlenecks occurred during the simulation period. Both routing protocols and produced nearly identical delay performance due to the static network environment. And coming to the delivery ratio, each of the 20 nodes generated traffic at 1 packet per second through the simulation duration. A total of 1800 packets was transmitted across the entire wireless sensor network. All 1800 packets were successfully received at the destinations, resulting in zero packet loss. This produced a packet delivery ratio of 1, which equals like almost 100% delivery success. The static topology and reliable routing paths greatly contributed to this high PDR value. And the next slide is energy consumption. Here, energy efficiency is critical in wireless sensor networks because node batteries have limited capacity. On average, each node consumed approximately 126 energy units during the simulation run. Remaining energy values has dropped below zero, indicating that completely battery depletion is done by the end. And radio transmission operations accounted for most of the energy usage compared to computation or routing logic. Both routing protocols showed similar energy consumption patterns under like static network conditions of different conditions. Coming to the code. So this is our program. And to just show a little bit of running. So these are the plot files that I've generated. This is the delay one with CDF, and this is the histogram. This is the energy consumption and the delivery ratio. The rest will be continued by Harsha.
Hello, Professor. So in this slide, I'll be discussing the main insights gained from the wireless sensor network simulation. So to begin with, when comparing the hybrid routing approach, baseline routing approach, we found that their performance was quite similar in a particular setup. This is mainly because our network topology was static and there was no significant changes such as node mobility or heavy congestion, where a hybrid protocol would normally show clear advantages. So another important observation that we saw is related to network stability. Throughout the entire simulation, there were no noticeable signs of congestion, packet loss due to link failure, or major disruptions. So this stable environment allowed this network to maintain a high package delivery ratio, which indicates reliable communication between the nodes. So we also noticed that energy consumption was determined by radio transmission. This is expected in wireless sensor networks because transmitting data requires more energy than processing it. This results emphasizes how important it is to optimize transmission power and design energy efficient routing protocols if we want to extend the lifetime of the network. So finally, end-to-end delay remained very consistent. This consistency can be attributed to the predictable traffic generations and the lack of disruptions in the network. As a result, the packet paths were stable and the data was able to move smoothly from source to the destination. Speaking of the conclusion, in our project successfully met all of its objectives by delivering a complete simulation and detailed analysis on the wireless sensor network. So we were able to design, implement, and deploy the specific scenario assigned to Group 7 using the Omni++ simulation environment. Our framework was able to reliably capture all the critical performance metrics, including end-to-end delay, packet delivery ratio, and overall energy consumption. One of the key strengths of a project is that the process is fully reproducible from configuration to data analysis. All the steps are clearly defined, which means the same results can be validated in future experiments as well. Throughout this project, we gained a deeper understanding of how routing strategies, traffic patterns, and energy use affect the overall performance and efficiency of wireless sensor networks. The next slide. So to conclude with, this project allowed us to explore real-world applications of wireless sensor networks and strengthen our skills in network simulations, data analysis, and performance evaluation. So we truly appreciate the opportunity to present these findings. Thank you so much.
Yeah, thank you.